Okay, question 4 in page 23. Just turn over to a new page now. We've got 3 times 10 to the power of 5 brackets, don't really need them, times 3 times 10 to the power of 7. Again, this is a calculator unit, but I'm going to show you how to do it without a calculator. 3 times 3 is 9, times 10 to the power of, just add the 5 and the 7 as before, 10 to the power of 12, and that's beautifully easy. That's lovely. Now, if you've got a more complicated standard form sum, again, you're allowed to use your machine. So you type in 3, then you press the exponential button, which is the power button, EXP, and then you press the 5, so that takes care of that little bracket there. Again, you don't need brackets when you multiply, but now you must press multiply, so we're about to multiply something. 3, then the exponential button again, and then 7, and then you press equals. So let's just review that. 3 exponential 5 means 3 times 10 to the power of 5. The times is dragged down there, and 3 exponential 7 means 3 times 10 to the power of 7. That takes care of that, and that should give you the same answer. Alright. Now the more modern Casios have, instead of an EXP button, they'll have something like this. It's called times 10 to the power of button, and I think they might have a little X up there or something. So every time, instead of pressing the EXP button, you press the times 10 to the power of X button, and that will take care of the exponential side of things. Let's do another one. 5 times 10 to the power of 5, I believe. Yes. Times 3.2 times 10 to the power of 9. Now, if you don't like to use EXP buttons, you can of course work out the 5 times 3.2 straight away. So I'm going to do that with my calculator. Nothing wrong with doing it like this. So 5 times 3.2, I make that 16 exactly. So I've got 16 times 10 to the power of, well, 5 and 9 is 14, but that is not standard form, and if you're required to write it standard form, let's do it properly. We've got to call it 1.6 times 10 to the power of 15. Now let's just think about that. 16 followed by 14 noughts. You're making the point come back one more place in the left in the negative direction. So we owe it a power. Is that alright? So we're taking one power off it and paying it back. So 16 times 10 to the power of 14 is not standard form. It's not wrong, it's just not finished. It is in fact 1.6 times 10 to the power of 15. That's perfectly correct. So envisage it, 16 followed by 14 noughts, or 1.6, then you multiply it by 10, 10, 10, 10, 10, 15 times. It will give you the correct number of noughts. Alright, so that's how you do that one. What else we got? Let's do something more challenging. I've got 3.9 times 10 to the power of 8 divided by 1.3 times 10 to the power of minus 5. Now again, I can use all these EXP buttons if I want to, or the times 10 to the power of buttons if I want to. I'm choosing not to, but I can use my calculator to do 3.9 divided by 1.3. So 3.9, divide that by 1.3, that's going to give me exactly 3. I should have seen that one coming, shouldn't I? Times 10 to the power of, well, 8 minus 5 is 8 plus 5. That's 10 to the power of 13. Alright, let's just do another one. I think I'll turn over the page really, just to, there you go. We've got one of these. We've got 5 times 10 to the power of 5, careful, plus 3 times 10 to the power of 6. Now again, if you use your calculator, it's dead easy. I'm choosing not to use a calculator. You can't add the 5 and the 3 because the powers are in different places. So this is what you have to do. Well, we got 5, and there's your power of 5. 1, 2, 3, 4, 5. There we go, 500,000. But we have 3 times 10 to the power of 6. Look at this. 1, 2, 3, 4, 5, 6. Now, with all our zeros lined up properly, we can add them. 0, 0, 0, 0, 0. 0 plus 5 is 5. And 3 plus nothing down there is 3. So what have I got in standard form? I've got 3.5 times 10 to the power of 1, 2, 3, 4, 5, 6. There it goes. Let me show you another way of doing that. Let's take a good look at this. I'm not sure if this is conventional, but I'm going to teach you anyway. In order to go another stage further, if I convert this to a power of 6, this becomes 0.5. Contemplate that just for a minute. 0.5 times 10 to the power of 6 added on to 3 times 10 to the power of 6. Now look, I've matched the powers. Now we're free to add. What is 0.5 times 3? Answer 3.5. And they're both 10 to the power of 6. That could be a quicker method if you can grasp that one. Alright, I think I'll do just one more for the fun of it. I've got pages and I think I've got time as well. Let's do the last one because it looks horrific. I've got 5.2 times 10 to the power of 4. I want to subtract 5.2 times 10 to the power of 3. Again, the powers are out of order, really. This is of a higher order than that one. It's got an extra power on it. 4 beats 3 by exactly times 10. So I want to match these two right now. So as I showed you before, leave that as it is. 5.2 times 10 to the power of 4. Take away 0.52. Okay, so I've gone back 1, pay back the power. 10 to the power of 4. Now I can quite happily subtract these. So what I'm doing really is 5.2 take away 0.52. Now we'll use my calculator for that. 5.2 take away 0.52. That gives me 4.68 times 10 to the power of 4. Okay? And again, you can use your EXP button just to push this straight into your calculator and avoid this middle step if you don't like it. But again, it can be done by manipulating the powers to make them match. That's correct. So what I'm going to do now is just one last question. Question 6. I really liked it. I think I've got space next door. Yes. Alright, so question 6. It says a rectangle. So straight away, best draw a rectangle in order to stick numbers on it and make life easier. Just helps to see what's going on. Has a length of 1.4 times 10 to the power of 4 meters. This is huge field. And he's got a width of 2.2 times 10 to the power of 3. So that's massive, isn't it? Calculate the area and the perimeter of the rectangle. Give your answer in standard index form or standard form. Well, the perimeter is the distance all the way around it. So we've got 1.4, and that's there as well, and a 2.2, well, that's there as well. So let's just do the perimeter. I've got 2 lots of 1.4 times 10 to the power of 4, and I've got 2 lots of 2.2, just the point there, times 10 to the power of 3. Alright, so what's that going to give me? That's going to give me 2.8 times 10 to the power of 4 plus 4.4, because 2 times 2.2 is 4.4, times 10 to the power of 3. Again, I'm trying to avoid using calculator. Let's try and match the powers a little bit. So 2.8 times 10 to the power of 4 plus, well, 0.44. I took a power off, paying back, times 10 to the power of 4. Now I'm quite free to add. So what is 2.8 plus 0.44? Let's talk to my machine now. 2.8 plus 0.44. That's going to give me, that didn't work, 2.8 plus 0.44. That should work. Okay, I've now got 3.24 times 10 to the power of 4, and it's in meters, I believe. Yep, it's in meters. That's that. As a perimeter, the area is dead easy. It's any old standard rectangle. We multiply the length by the width. So here I go. This is the area. We've got 1.4 times 10 to the power of 4 multiplied by 2.2 times 10 to the power of 3. I'm just going to go ahead and multiply 1.4 with the 2.2. So I've got 3.08, and then simply add the powers because I'm multiplying. The 4 and the 3 would give us 7, 10 to the power of 7, and that answer will be in meter square. And that's the end of